Hi, today we're going to talk about modular architecture in Unity. Modularity is the most important and powerful principle when it comes to clean architecture in Unity applications, but I think that most developers are not utilizing it to full extent, so I'm going to share my approach to architecture and I hope you find it useful. Let's get started. So first let's take a look at example of bad architecture. It is a real project that I have done 13 years ago. It is a tower defense game. We have different kinds of towers that shoot differently, different amounts of enemies, different patterns, different targeting, different cooldowns, different areas of attack, different damage distribution, all this kind of basic stuff. And we just need some tower scripts that actually need to be able to do this. So what would be the absolute worst approach to take? That would be to have one tower script that's gonna implement all this functionality. Because the towers are different enough so that they have functionality that is not necessary in every tower. And it's gonna be just spaghetti, it's gonna be a lot of if statements, a lot of checks to make this work, and it's just gonna be a complete mess. It's gonna be a huge class, it's gonna be impossible to maintain. Only one person at a time will be able to work on it, and it's just not good. No way to go. What is the second worst approach that we could take? That would be to have classes inherited from this class. Because in this case, yes, we have abstracted a little bit, we have separated functionality of each tower a little bit, but still all of this is tightly coupled together, and it means that changes introduced to each of these classes, or maybe when we add new classes, there's a chance that it's going to affect the entire hierarchy. For example, we have added this tower and we decided that we actually need functionality from this tower in this tower, and in order to share it, we have to move it from this class back to the base, and from the base is going to be accessible in this tower. And it means that we had to change 3 classes just to have this class be able to do something. Or we're going to duplicate the code, which is even worse. And this is not even the worst case. Worst case is that we moved the code to the base class, and now every class in the hierarchy has to make some changes in order to adapt. So you're going to constantly move code around, and you will never end up with something that is actually good, because you have too much functionality to share between all of these towers. But you have the inheritance structure that's linear and is not able to accommodate all of this functionality in a clean way. Even more so if you extend and add new features. This approach scales so badly, because whenever we grow this hierarchy, the mess just grows and it all affects each other, and again, you're just never going to be able to share the functionality. And then you maybe will add another hierarchy to this. Maybe you move the unit into its own hierarchy, and now you need to share functionality between those two hierarchies. And how do you do that? You add an interface on it. This is actually a solution that is to the problem that shouldn't even exist in the first place, and I would say that most of the time when I see interfaces in Unity, they are just a sign of architecture that should have been more modular instead. So I wouldn't recommend this. No amount of me talking is gonna actually convey how actually terrible this is. Now let's try to figure out what we actually did wrong and why we did it. And I would say that it is because we thought about things in the code in a level that is too high. We basically were thinking about things in terms of concepts. When it comes to code, things like tower, character, player, enemy, gun, car, those things are basically just high-level concepts that don't make much sense for the code. They're just not useful and not productive way to think about it. So instead, I suggest that we think about things in terms of functionality. And it means in terms of systems, logic, and data. And when we do it, we start to go from high level to low level. And instead of thinking about some abstract big concepts, we are now thinking about actual things that the game needs to be able to do. It means that we are thinking about the systems of the game and logic that is in those systems and the data that those systems require. For example, when we want to be able to build things, we can now think about it in a more abstract way, and we just want to be able to build things. We don't need to care if it's a tower or not, because we just need a system that builds things. So we create a build system, which is a class that is kind of a singleton, and then we have a buildable component that we can put on anything, and it will allow it to be built. And then let's say we need towers to be able to shoot at things. And again, we think about it as a separate feature, and we make a system that shoots. So we just create a component that shoots at things, and we create a trigger component that can register enemies to shoot at, and so on. Now we are thinking on a lower level, and we are thinking in terms of features and functionality. And now we can realize that the tower might be almost a useless concept when it comes to code, because now instead we are thinking about the actual things that we need to do and a little bits of logic and data that actually need to do those things, without necessarily needing to know what high-level structure they are part of. Now let's take a look at the modular design process, and I will show you some other advantages that it actually gives you. So we have the building system class, and a buildable component that we put on the tower. We made a pathfinding system, and we added path blocker that blocks the path in that system where the tower is built. Then we added the shooting things, and we added some stuff that's needed for UI, like name of the tower, as a separate component. So now what is really good about it is that we actually worked on 4 separate features that don't even interact with each other, except maybe UI and building system are a little bit connected. So it means that 4 developers could work on this same tower at the same time and not even interfere with each other's code. And it's a huge advantage. When we have one class, it is completely impossible, and when we have hierarchy of classes, there's a high chance that we're gonna interfere, but here they can work easily and effectively without any issues. Also, when you are a solo developer, it means that you can work on this tower one feature at a time, and it is also more efficient for you. It is cleaner, it is easier. When you completed a feature, you just complete it and forget about it. You just work on the next one, and then you work on the next one and the next one. It also gives you a nice sense of progress, but most importantly, it just allows you to complete things faster and not have to come back to them and fix them and change them, because these systems don't interfere with each other, and even if they do, it is in very minor ways that are very easy to fix. And in the end, this structure is way cleaner, it is less prone to bugs, and it's just better all around, and you will be much happier with the structure that you have here, because things are not going to be in places where they don't belong. Things are going to be nice and clean, and they're going to be structured in the way that you actually need. Let's take a look at some other examples. Here are some examples of how this approach could look in our tower defense game. So starting with this tower, we have a basic tower that has 4 components on it that allow it to be built and to be able to shoot things. And if we want this tower to be able to shoot in many things at the same time, independently, we don't need to mess with the code, we just put multiple shooters on it. If we would want it to shoot at multiple different areas, then we could put multiple triggers on it. And keep in mind that inheritance is not always a bad thing, it's actually very useful. It's just when you use it is the question. You can't use it when you have objects that are too big, because then there's too much functionality that is crammed into a linear structure and it's just not working. But when you have little objects that have very narrow functionality, then you can do it, and it's very useful. For example, here we have the attacker class that can attack in different ways, and we implement it as a hierarchy. One version of the attacker is a shooter, so it shoots at things, and the other one is a damage area, which just does damage to the things in the trigger, for example. So we created these 3 classes that are very nice and clean and easy to work with, because they are small, they are doing exactly what they need to do, they don't contain the code that they don't actually need, and there are very little chances that changes are going to propagate back or to the other classes in this hierarchy. And even if they do, it is not a big deal because the classes are very small. So in this case, the inheritance is actually a great approach. The next great thing about this approach is that you can take these pieces of functionality and put them together in new ways that will create basically a completely new things in your game. Or maybe you will add minimal changes, little new components, and you will get a completely new item in the game. For example, we added traps that can be built on the path and they damage enemies that walk through them. So for that, we replaced the shooter with the damage area, and we removed the blocker component, so now trap doesn't block the path, and we added health components so it can be destroyed. So we probably didn't need any new components in order to make the traps work. We just put the components in a different way together and it works. And then let's say we have units that we can build on the path to defend. In this case, they're buildable, and they also are very similar to towers. They also have the trigger, they have the attacker. The main difference is that they have the mover component that allows them to move. Then of course we have enemies. In our case, enemies can attack things, and they have component that allows them to follow the path, but they also have the blocker and the health. And all this means that that we have very extendable and scalable code, because adding new functionality and new code means only adding new little things one at a time and usually not affecting the other things or doing it in a minimal way. And this is great for a simple game like Tower Defense, but it is even better for multiplayer games, and this is going to be the next example. In multiplayer games, it is even more important to have modularity because you want to be able to separate between the client code and the server code. In this example, we have the client components in yellow and shared components in green and server-only components in blue. You really want to be able to do this separation easily in multiplayer games because you want the server to be light and clean and not have the client stuff, not have any graphics that server doesn't need on it or anything else that will slow it down, because the server costs money and you want it to be as efficient as possible. And on the client, this modularity also helps in many different ways, but mainly the multiplayer projects are just so complex and so big that they benefit even more from modularity. And the scalability that you get from modularity is of course even more useful when the project is bigger. The scalability that you get from modularity is crucial in this kind of project because of its scale and complexity. Now, I have outlined a lot of advantages of modular architecture, and I'm sure that almost all developers that develop in Unity know about modularity and its importance. It's just, it is not clear how much modularity should there be. And I will try to show you some examples that I personally have come to as the sweet spot of modularity, because you can have too much modularity and you can have not enough. We're going to talk about a specific system, in this case interaction system, and this is the example of how I used to think about this kind of systems years ago and how I thought about them after about a decade of experience and how I think about them to this day. First, in this case, we have objects in the game represented as high-level classes. We have a class for the door, for the chest, for the drawer, and we need to be able to interact with them. We can't really have them all inherit from one object, so what would be the solution to that in this case would be to use an interactable interface. And many developers, I'm sure, would even recommend this kind of approach, and they are using it. But I would argue that if you have to use an interface to narrow down functionality of things and to share it and to provide access to it, it probably means that you instead should have abstracted it into a separate component. And in the second example, we did exactly that. Instead of our interactable interface, interaction is a component by itself. So if we are able to interact with a thing in many different ways, we just put multiple interactions on it. For example, to be able to open something, you put open interaction on it. To be able to talk to it, you put talk interaction. And the interaction system is going to detect these components on the objects and be able to activate them. And when they're activated, they're gonna actually execute the logic of that interaction. So they're gonna jump into your inventory maybe, or they're gonna start talking to you, whatever you want. So you just need to put one little component on anything you want in order for it to have the functionality. And I didn't use this example accidentally, because I think this is actually the best example, or one of the best examples that I can give you that demonstrates the optimal level of modularity, in my opinion. If you have interactions like this as separate components, I think this is a good sign that your architecture is modular enough. Another example that I can give you is actually having names as separate components. If a name on an object is a separate component, that is a good level of modularity. I'm just going to give it to you as my opinion and as a hint, because I can't really explain to you enough in this video why I think this is the optimal level of modularity. A name as a separate component, or even level of a creature, for example, in the game in RPG, as a separate component, or interaction as a separate component. For me, this is the level of modularity that I found optimal. If you use this as a pointer and you test it and see how it works for you, I think you're gonna come to the understanding that I have here as well. So finally, I have said all of the most important things that I wanted to say, and I could talk about how to identify what should be a module and how those modules should fit together. But really, I gave you the examples, and those are going to be the most useful. And now you're going to have to work, of course, on your own to figure out what is the best approach for you. If you're not used to this kind of architecture, then of course you're going to have to work with it and develop a sense for it. But with experience, you're going to just look at any feature that needs to be implemented, and you're going to know exactly what set of modules it is. And the resulting code is just going to be much more clean, extendable. It's going to be really nice to work with. And if anything, I would leave you with this picture, and I would recommend you to try programming in ECS, because personally, when I came back from ECS to object-oriented, my code became so much cleaner, so much more modular, and things became so much less coupled. so maybe give it a try. And I hope you found this video useful. This is my first ever tutorial, so it's probably pretty bad, but I'm trying my best. And if you have any feedback or questions, I will be happy to hear them and answer. And thank you for watching.